Let us take few examples. F of n, if it is 2n square plus 3n plus 4. Suppose this is a function. So 2n square plus 3n plus 4 is less than 2n square plus 3n square plus 4n square. So this 2n square plus 3n plus 4 is less than equal to 9n square. For all n greater than equal to some value, you can find out from which value it is starting and just put 1 there. So this is greater than equal to this one. So this is C and this is g of n. So it is f of n is big O of g of n. So g of n is what? N square. F of n is big O of n square. Now for the same function, I can say 2n square plus 3n plus 4 is greater than equal to 1 into n square. So it is omega of n square. So even I can write omega of n square. I made it as 1 into n square. Now same thing, 2n square plus 3n plus 4 is lying in between 1n square and 9n square. So this is theta of n square on both the sides. Next, if f of n is n square log n plus n, then n square log n plus n is less than equal to 10n square log n. I just wrote some value, greater value there, and here it is less than equal to 1n square log n. So both the side I got n square log n and n square log n, and this is smaller, this is greater than this one, and this is smaller than this one. So both the side I got n square log n and n square log n. So this is big O of n square log n and omega of n square log n, as well as this is theta of n square log n. So all three I have written them together here. Now if you observe in our this orders, we have not written n square log n. But if I write n square log n comes in between n square and n cube. N square log n is greater than n square but less than n cube. So this is the combination of n square and log n, and for this also you can specify a class here in between those two. You can mention a class. Next, if a function is n factorial, then let us see. N factorial is nothing but n into n minus 1 into n minus 2 into goes on to 3 into 2 into 1. So if I write in reverse, then 1 into 2 into 3 goes on to n. Now this is greater than less than or equal to what? See, as a practice what we were doing, everything we were making it as n. So here also I will make it as n into n into n into goes on to n. And this is less than or equal to what? So as a practice we'll make everything as 1 into 1 into 1 into goes on to 1. So this side I get 1 and this is n factorial and this is n power n. Now for this one, for n factorial, I don't have any smaller value here and I have to take it as 1. And if I take larger value, it is n power n. Upper bound is n power n. And both the side I am not getting same thing. I am not getting same thing. If I get same thing, then I can take it as theta. So what I can write? I can write big O of n power n and omega of 1. So the lower bound for n factorial is 1. Upper bound for n factorial is n power n. Right? So here we cannot find the tight bond or average bond or theta for n factorial. So if you try to put n factorial here, Class is not there for n factorial. But if you try to put it there, then for the smaller values of n, it will be nearer to this one. And for the larger values of n, it will be increasing and going up to n power n. So you cannot fix a particular place for n factorial. You cannot say that n factorial is always greater than n power 10 and less than n power 11. You cannot say that. You cannot find a place for it. You cannot find a place for it. Right? So it's greater than equal to 1 but less than equal to n power n. So upper bound is n power n and the lower bound is 1. So this is the function for which you cannot find the theta. So now upper bound and lower bound are useful. As I already told that when you cannot mention theta bound for any function, then we go for upper bound or lower bound. So yes, here we have taken upper bound and lower bound of a function. Let's take log n factorial. So for log n factorial, if I write log of 1 into 2 into 3 and so on to n, then this is less than or equal to log of, as a practice we'll make everything as n. So n into so on to n. And it is less than log 1 into so on to 1. So this side will be 0 but we write 1 and this is log of n factorial and this is less than equal to, this is log of n raised to n and that will be written as n log n. That power comes on this side and it is n log n. So now you can see that for n log n factorial also, upper bound is log n power n and the lower bound is 1 and there is no tied bound for this function. So the factorial function, we cannot define the tied bound. So we go for upper bound as n log n and lower bound as 1. So there is no tied bound. So now you have understood when to use a big O notation, when to use omega, and always theta is preferable. If you are able to find theta for any function, that's better because that is a tied bound. And if you are using upper bound, big O also, try to use a tied bound. Don't give a very far away value, a larger value. And if you are using lower bound, don't give any smaller value. Try to give a nearest value for a function. Suppose your function is n square, so try to give it n square only. Though writing n log n or root n is also correct, true, but not meaningful, but not useful. If I ask you that I want to buy a mobile phone for my requirement, what could be the better price? So any price for a mobile phone that's available in the market. So suppose you have some idea about the mobile phone and you said that you can buy a mobile phone around 20,000. So you are giving me nearest figures. If I say, if you don't know the nearest figures and if I ask you, tell me something minimum, so you are saying that 18, 19,000 or maximum you can say 21, 24,000 like that. So you are nearer only. But if you say minimum means 2,000, 3,000, so your answer is correct. I can get some mobile phone in 2, 3,000 also, smartphone also, but that will not be a suitable one for me. But your answer is right, but it's not useful. And if I ask maximum, so you say 1 lakh, 2 lakh. So even for 1 lakh, 2 lakh mobile phones are also available. Answer is correct, but not meaningful for me. So same way, when you have any function n square, then you can say n square, that is the answer, perfect answer. So giving theta is the right one. But if you are writing omega, so I am not sure whether you are giving me nearest or not. That is the problem with big O. It may be nearest one or it may be bigger than that one also. But theta guarantees that you have given the exact figure, exact notation, exact time complexity. When you are using omega, then also it means that you may be giving a lower value, may or may not be nearest one. So that's why big O or omega are used when you are not sure about the exact one. Right? That is the meaning it gives. So that is much suitable for n factorial and log n factorial, but you can use them for any purpose. It's not a rule that you must not use, you must use theta only. You can use any notation. So when you are using omega means maybe minimum this one and maybe it is more than this. The time may be more than this also. That is the meaning. Theta means exactly this much time only. So hope you have understood this topic. This is very, very important topic. Now in coming video, that is next video, you can find the properties of asymptotic notations. You can watch that video.